Hello everyone, welcome to my channel. This is Ravi Shankar. Okay, so today we are going to learn time complexity 1. So, time complexity and space complexity, these are two major factors that we can these are the major factors where we can analyze the algorithms. Okay, so here the big O comes into a picture. So we will not talk about big O exactly right now. We will just go with the introduction of it, and we will look into a counting of the iterations. So suppose if the code is taking this much time, so that much count, we can say that this much out iterations are happening. So before starting this, I just want to tell you what is time complexity and space complexity. Means you have a machine and you have a space, and in that machine you have a written code, means your algorithm. So now your algorithm is taking extra space or taking extra time to execute the code. So that extra execution of time is nothing but what? Time complexity. And extra space it is taken by your algorithm, is your algorithm require extra space, is nothing but space complexity. So this is just basic idea of this. Okay, so why big O concept has occurred or they followed here or everything, we will discuss one by one. First let's start with the introduction. Okay, so before that, I want to tell you that to count the iterations means only not just counting the iterations. Okay, there are some few topics or few concepts that we need to follow to find it. What are those? Okay, let's talk about it. One second. Okay, so let's talk just without wasting a time. Let's start learning. Okay. Okay, first tell me that sum of n natural numbers. Sum of n natural numbers. So before that, this video I have shown you the 1 to 100 numbers, in between numbers sum. So what we have followed there, n into n plus 1 divided by 2. This was the formula there. Okay, so but suppose it was, just think, it was one simple 1 comma 100, and there were no difference, like it was a continuous natural number, like 1 2 3 4 till 100. So that's why you easily applied this. Got it? So you can easily apply that 100 into 100 plus 1 divided by 2 is equals to nothing but 100 into 101 divided by 2 is equals to 5050. You see here it is 1, so means your number is taking or incrementing by 1. So this is natural number, always natural number generated by previous numbers, and previous number addition and current number becomes current number. Simple, like 0 plus 1, if you do 1, 1 plus 1 is nothing but 2 plus 1 is 3. So for that, this formula is okay. Okay, no problem. So how, what about this? Okay, I'll just ask you. Okay, just tell me the answer. 1 4 7 chain 13. Okay, just tell me that what is or which is the next number after 13. Can you see something, like something is common in there? What it is? The difference. So difference between 1 to 4 is what? Nothing but 3. Difference between 4 and 7 is nothing but what? 3. Difference between 7 to 10 is nothing but 3. Difference between 10 to 13 is nothing but 3. Then 13 to 3 is what? 16, right? So next number is 16. So if I ask you, give me the sum of this all numbers, how you will find that? Okay, how you will find this? Okay, this is not like, it is not following the rule of natural numbers like 1 2 3 4. There is a pattern that is 3 difference, and all numbers are incrementing by 3. Okay, numbers are natural, but it is not following the way of how the natural numbers increment. But here, just tell me the sum of this 1 4 7 10 13. You can do it, because these are few numbers or 5 numbers only, so that's why you can able to make it one addition number. Okay, so now instead of that, we have one concept, that is AP. What it is? AP is nothing but arithmetic progression. What is arithmetic progression? Means arithmetic progression follows the terms, and it checks the first common difference, and then it checks the total numbers, and then it gives you the actual output. Okay, so now suppose sum of n terms of AP, how we will find it? Okay, so before that, I just want to ask you, arithmetic progression, if we have said, so your A is what? 1 is what? It is A. Now it is 4. So how much, after the adding a 3, you are getting a next number? Means D is what? It is your common difference, that is nothing but 3. So what you can say, A plus D is what? 4. Next, what it is? How you can say that? A plus 2D, right? Then 7. Then it is third term. A, these are the terms. Okay, this is 2. Oh, sorry. This is 2. This is third term. How you will find a fourth term? Same, A plus 3D. Okay, till it will go A plus n minus 1 into D, because you don't know this will, how much it will be. It will be infinite or n, so n minus 1 into D, so that will be your nth terms. Got it? So in this way, if you are finding the terms, then how we can find the sum of n terms with the help of this A and D. So there is formula of AP, that is n divided by 2, 2A plus n minus 1 into D. This is the formula of what? This is the formula of AP. So now let's put the values and check the answer. Okay, just tell me that n is what? Total numbers. How many? 1 2 3 4 5. Okay, 5 divided by 2. 2 is constant. A is what? First number is what? First term is what? A is nothing but first term. It is what? 1. Okay, plus n is what? 5 minus 1. Okay, into D. D is what? D is what? How difference is? 3, right? So let's solve this. 5 by 2 into 2 plus 8. Simply 2, and this 5 minus 1 is 4. This is 5 minus 1, and this is d. D is that the difference. So difference is that is 3. Okay. So for this example we have a difference 3. That's why we kept 3. So I thought it is 2. So it is 3. So 2 is 2. 5 minus 1 is nothing but is 4 into 3 is 12. So it is 12. So now how will solve? 5 divided by 2 into it is what? 14. So 14 into 5, what it is? 70 divided by 2 is equals to 35. Let's calculate 70. I'm not good in that much I'm not much good in maths. Is yeah, it is 17 divided by 2 is nothing but 35. Let's count. 13 plus 10, 23, 30, 34 and 35. We got the 35. So arithmetic, when it works, when you have a common difference. Same example let's take again. Okay, you have a 1, you have a 3, you have a 5, you have a 7, you have a 9. So just tell me the first term, means a is what? Nothing but 1. Tell me the difference in between. You can see the difference, right? 1, 3, there is 2, 2's difference. 3 and 4 in between, 2's difference. 5 and 7 there is 2's, and 7 to 9 is also 2. So difference, common difference will be what? 2. And n is what? 1, 2, 3, 4, 5. So n is 5. Let's put them in a formula. What formula says? N divided by 2 into 2 into 1 plus 5 minus 1 into 2. You have seen. See, n divided by 2, 2 into a means what? 1, and n minus 1 means nothing but 5 minus 1 into d is nothing but 2. Okay, let's solve this. 5 divided by 2 into 2 plus 8. So 5 divided by 2 into 10 is nothing but what? 50 divided by 2 is equals to 25. Let's take a count. 1 and 3 is 4. 4 and 5, 9. 9 and this 16. 16 plus 9 is what? 25. It is nothing but 25. So this is arithmetic progression, that you have a term which is a term of some natural numbers, means you have an n natural numbers with the terms, and there will be a common difference. There will be a common difference. In that way we will apply the arithmetic progression to find their time complexity. Okay, just understand this, how we can find a sum of those numbers where common difference is there. So there we can follow the arithmetic progression. Got it? Okay, so now second topic, let's talk about second. So next is what? GP. What is GP? What is GP? GP is nothing but geometric progression. Why we say geometric progression here? See, AP and GP is there. These two concepts are enough to learn the time complexity and space complexity, means how you can analyze the complexity with these two concepts only. That's why I'm going to teach you these two only. So forget about if there are a lot of progressions we don't need as of now. So let's take an example of GP, what GP follows. Okay, so you have a 2, you have a 4, you have a 8, you have a 16, you have a 32. So what is the next number here? You can see 2 and 4. 2 is nothing but it is double, again it is double, again it is double, again it is double. So means you have a ratio. So what is the ratio now? Ratio, it means the common relation. The ratio is nothing but common relation. So let's talk about this. If you have a this 4 and if you want to find the this previous number, so what you will do? 4 divided by 2. Again if you have this, so you want to find the 4, then now what you will do? 8 divided by 4. So again if you want to 16, so what you will do? 16 divided by 8. So now see, 4 divided by is what? Nothing but 2. 8 divided by 4 is nothing but what? 2. So 16 divided by 8 is what? 8. So common relation in between is what? R is what? 2. So common relation or ratio is nothing but 2. And how many numbers are there? So 32, you know that it how it came, you understood, right? So now just tell me that this thing, how we can find the sum of this term. Sum of this term, how we can find? See, we can't say that there is a common difference. We can't say we can also follow the AP here. We can't follow the AP here. We need to follow the GP here, because the common relation means common ratio is there. There is no difference. Okay, so for example, see here it is double, but not a common difference. 2 and 4 is what? 2. But 4 and 8 it is what? 4 difference, not actual 2. So common difference is not there, so that's why we can't follow the AP program, means arithmetic progression. But we have found the ratio in between is what? 2. So see, 2 is 2, 2 2s are 2 is 4, 4 2s are 2 is what? 8. So ratio is what? 2. So that's why I have written 2 here. Now how you will say that this is following the ratio? See, simple, I will say that suppose your first term is a is nothing but what? 2. Second time it is becoming 4, so how much you will add? 2 into 2, right? That means 2 is nothing but what? Your R into R. So next time what you will do? You want to make it 8, right? So a is your 2, so 4 is nothing but previous 4, but 4 is what? R. So R is nothing but 2. 2 square is what? 2 square is what? 4. 4 into 2 is what? 8. Again what you will do? A into R of cube. Again this is comma. A into R of 4. So how long it will go till n terms? We can say that a raised to r into n minus 1. This is the n term. How n term came this? See, for first it is 0, this is 1, this is 2. So till, if it is starting from 0, if you want to find the term of this, so how we can say that? We can say 0 minus means n minus 0 plus 1 is nothing but what? N plus 1, and we are taking one step forward backward here, so means we are checking previous one, so it is nothing but n minus 1. So simply n minus 1 r n minus 1 will be the r raised to n minus 1 will be the nth term here. So what is the formula of this GP? What is GP formula? GP formula is simple. A into r raised to n minus 1 divided by r minus 1. Let's take an example. So let's take one more example. 1, 3, 9 and 27. So let's find the GP of this term. So let's just tell me that A, first term is what? A is nothing but 1. R is what? The common ratio is what? 3. And N is what? How many numbers are there? These are the 4 numbers. Okay, we have written it. So let's put into the formula. A is what? 1 into R is what? 3 and N is what? 4 minus 1 divided by 2 minus, sorry, it is now 3. Relation means ratio is 3. So let's, it is 81 minus 1 divided by 2. I'll just clear this. See, nothing but 80 divided by 2 is what? 40. Let's check, cross verify. This is 4 and 4 and 9 is what? 10 and 13. 13 plus 17 is nothing but 40. This is the GP of this term where a ratio we have. So in this way we can follow it. So this was about a GP. So GP, that means like if common ratio is there, and then we can find the actual answer of the numbers sum. Okay, so one more thing I want to tell you, that is this property, I guess I told you in the last lecture. A raised to x is equals to what? This is x. And suppose if it is log of 2 raised to 8 is nothing but 3. Got it? This you know. And the same one thing I have told you, suppose 0 to 9 you have to count the number, the total numbers in between 0 to 9. So this is inclusive. How you will find? So b minus a plus 1, this formula should remember. So b is not nothing but 9 minus 0 plus 1 is equals to what? 9 plus 1 is 10. So how many numbers are in between 0 to 9? This is nothing but inclusive mean. When square are there, so it is nothing but inclusive. So let's talk about 2 to 8. 8 minus 2 plus 1 is equals to 6 plus 1 is equals to what? 7 numbers. 7 numbers are there. Okay, so this is very basic. Suppose if you have a big number, suppose if you have a big number, that is 321007, it is possible to count on your finger, count by a finger or count on finger? No, right? So how will do? 1007 minus 3 plus 1, it is nothing but 4 plus 1 is 10 to 5. So suppose if you have a number, okay, simple, if you have a starting, someone told you that from 3 to 107 how many numbers are in between a list. So simply if we saying that the index of this is 3 and this is this index is this, so please give me the count. So this b minus a plus 1 you will apply, you will just say that these are the numbers of element are present. Okay, so this was a very basic that I have told you. Like whenever we require it, we will discuss more in detail. So this is arithmetic progression where we see the common difference in between two numbers, means in a term, and formula it is. So for GP we have this formula. So let's box these two. Okay, and log log base a power, like power a of x is nothing but property says that x, it will, the log base 2 of 8 is nothing but 3. So 0 to n number count inclusive, we will say b minus a plus 1 is nothing but 10. So this is just basic. Okay, let's talk about how we can count the iterations. Suppose if you are using the loop for 1 to 10, so you can easily say that 10 means 10 is inclusive, so you can say that 1 comma 10, how many iterations are happening? 10 minus 1 plus 1 is equal to 9 plus 1 is equals to 10 iteration. But suppose if it is different, if the double nested loop or 3 loops, or I is traveling till n but j is not traveling, so in that case how we can find the count of iterations? So let's talk about this. I'll take one example one by one. Okay, let's talk about this, how we can count the iterations. So simply in this example we have a one function. So function, whatever function it is, we don't care about it now. We just need to follow the how many iterations are happening. Okay, so here how we can find it? See, s is what? This is what? 0. I is what? 1. Means your loop gonna start from 1 to n, means n is greater than or equals to I, means when your I never reach to equal to or less to, means you are equal to n, then only your loop will stop. And loop is iterating, means incrementing, your I is incrementing by what? Plus 1. So in this situation, how many iterations are happening? How you can find? Suppose if you have a number that is 1 and your n is 5000, so how you will say that the 5000 iterations are happening? So there must have something like common or something way that easily you can say that these iterations are counted by this formula using this way. So let's just talk about this. Is single loop, means nothing but one after one is happening. So we are just following gp, means 1 plus 1 2 plus 1 is 3 4 5 6 7 8 9 10. If n is 10, so how many iterations are happening? Nothing but 10. Okay, let's think in easy way. What is your I? 1. And what is your n? N is n only. So just tell me that what is the value. So as I say that b minus a plus 1, so simply n minus 1 plus 1 is nothing but n, right? This is plus, this is minus 0, so n is only there. Okay, so means suppose if now put any value in for n, you will get the output. See, suppose I said that 499. Okay, 499 minus 1 plus 1 is what? 498 plus 1 is equals to 499. So only the iterations are happening. How much iteration happening is equals to what? Your n. So means whatever input size comes to this function or inside this algorithm, so that number will be the n, and the time complexity of that is nothing but n. Is that simple? So this is following AP, because one iteration is happening after one. One means I is incrementing by 1, right? So there is one common difference is 1, so that's why. Or simply you can say 1 to n iterations are going, so you can just follow the b minus a plus 1. It will also give the answer. Okay, so for this function, as I am saying that if I is incrementing by 1 and your I is going till n, so iterations will be always n. So now don't say that like big O is n. Let's talk about big O later on. Let's talk about second example. Okay, now here you have two loops. You have two loops. How you can find the time complexity or the number of iterations, or how much number of iterations happening in this we said that suppose n is 10, so 10 iteration will happen. Now these are the two loops. How you can say that the n number of this much iterations are happening? So let's talk. Suppose you are always try to put your n value and try to get the number, then only say that this is the time complexity. Never just look at this I and this is and this is. Always go with a good way. So I will show simple in a table way. Okay, this is your I and this is your iterations. Okay, so just tell me that from where your I is getting started, from 1 until 1 to means 1 to where it is going, n means n is later on, so 1 to 1 iterations are happening, means nothing but how much it is, 1 iteration is happening. If your I is 2, so if your I is 2, again 1 iteration, 1 iteration will happen, means it is nothing but 2, 3, 3, this will go till n and this will go till n. Simple, right? So simply means this iteration is 1, this iteration is 2, this is 3. So simply this is the same case. So this is the same case where your I is what, 1, and your n is what, n. So simply n minus 1 plus 1 is what, n. The same way here, but it is not n, it is m. Just put m here, no? M minus 1 plus 1 is equals to what, m. So now this loop after this loop iteration, these iterations are going to start. So what you can say that you don't know the m, what will be the, how much m it will be. Suppose if it is n, simple case I am saying that, suppose if it is m, then you can say n plus m iterations are happening. Just say, simply put the values. Suppose this is 10 iteration and this is 5 iteration. Let's put 10 plus 5. This loop will take how much, 10 iteration. This will take how much, 5 iteration. But these are not happening like these are no, this loop is not nested, individually iterations are happening. So in that case what we do, add them. But suppose this loop is not traveling till m, this is also traveling till n. Now let's see, this is also taking 10 and your n is 10, this means also this is also 10. So how we can say that n plus n, so 10 plus 10 is what, 20. So 20 iterations are happening, but for n plus n, what you can say, 2n you can say. But 2n is nothing but was what, 2 into 10 is what, 20, right? Means only the big, so iteration is what, this is constant, right? You can say that whatever, how many loops if you are using, that will be your this, but at the end n is the TC for this. But if n is both sides same, but if it is m, then n plus m. Okay, this is simple way. Second, we have done third formula. See now, your s is 0, I starting from 0, then it is going till what, 100. So in this case, how many iteration will happen? 0, 100 minus 0 plus 1 is equals to nothing but 100 plus 1 is what, 101. Simply see, I starting from 0 and it is going till what, 100. So you just made b minus a plus 1, so you got 101, means the iterations will happen n plus 1. Got it? So 1 is negligible, 1 doesn't matter, means if it is 5 lakh plus 1, so 1 can't impact too much on your performance, right? So you can just ignore it. You can say 5 lakh iterations happening, means nothing but n iterations are happening. Okay, so in this case, all time whatever n will be here, so for this example let me tell you in detail. Okay, so as I said that this is taking 101. How you know that b minus a plus 1 is 101? Suppose if your n is 1 lakh, 1 is n lakh, but is your n going for iteration? No, right? Means whatever your size will be n, so that will not impact to your algorithm. The only iteration will happen for this is nothing but 101, which is a constant, means for every input this is a constant. So order of 1 will be the time complexity, means whatever n will be there, because we are not using n anywhere, right? suppose it suppose it would have a like n, then only we can say order of n are happening. But in this case, for each for each n the only iterations are happening 101. So for all input, your 100 is 100 is 101 is what, 101 is what, constant. So constant complexity always order of 1. So the complexity of this is what, order of 1. So this is very basic. If you following very seriously or you want to learn it, then you will easily solve this. Okay, let's talk about this. Okay, oh, this is not okay. Tell me this, your eye is starting from 1 till where it is going, and how much iterations this is here it is happening. Now you can say that you cannot say 1 comma n is equals to n. Just look in this program, your I is going till 1, and it is, means I is become first it will 1 and it will go till what, n. But how it is going, just see. Suppose if it is 2, 2 into 2 is what, 4. So means if your I was first time 1, second time your I will become what, 4. Mean nothing but it is what, I square, right? Means suppose if you have a I square, and I always will be a less than or equals to what, n. So I is less than or equals to n. Suppose if you want to make a both sides same, so if you remove the square, so I will be less than equals to what, square root of n. So let's talk how much iteration it is taking. I is what, means the your n is this and your I is this. I is 1 and this is your square root. Let's find it. Square root of n minus 1 plus 1 is what, nothing but square root of n. So the time complexity of this is what, square root of n, because this is taking double, right? This is taking double, means if you have I2, so but it is making 4, right? So as we have seen this same in our example, that is perfect square root in a first video or second video. Okay, so TC of this is what, square root of n. Just put any value, check. Suppose if it is 16, the 4 iteration it will take, because I is jumping into square, right? So when I will be a 1, 1 into 1 is n, it is not 1, 9 n. So 2 into 2 is 4, it is not n, n is 60, no? And 3 into 3 is 9. Now 4 into 4 is what? 16. Got it? Now 16 it got matched and iterations are stopped. So how much iteration is taken to 16? Only 4. So if you pass 16 into that, the iteration will be 4. So TC will be, again I am saying, square root of n. Let's talk about this. How log 2n? Simply that, suppose n, whatever n is coming, the first example we have seen that suppose if you have a number that is 8 and it going to divide by 2, so how much it will take? 8, 4, 2 and 1. So 1, 2 and 3. So 3 times if you divide it by 2, then only it will give the 1. So how we calculated it in the last video? Log if base 2 raised to what? Power of 8, nothing but what? 3. So how much it is taken? 3 here. So in this program, how it is happening? Your n came, right? 8, let's say. So I is what? I is nothing but also 8. So I is greater than 1 because you want to take it till 1, no? So I is greater than 1. Yeah, it is greater than 1. When it will become 1 equals 1, then iteration will stop. Okay, so this is the same program. So I is equals to I by 2. I is what? 8 by 2. So I will become 4. So again it will go up. So 4 divided by 2, it is 2. Again it will go and come inside this. So 1 is equals to 2 divided by 2. So how much iteration it took? See, for first it will came 1, 2, 3. So just put this log 2 of 8 is nothing but, as I said, 3. How much iteration it is taking? 3 iteration. Now put any number. Let's talk about 16. 16 to 8, 8 to 4, 4 to 2 and 2 to 1. This is 1, 2, 3 and 4. Log base 2 raised to 16 is what? 4, right? Let's try to implement. Let's try to apply in code. You have a 16 here. First time you came, 16 divided by 2, I will become 8. Okay, second time again I is greater than 1, so I will become 4. Third time you came, which is greater than 1, so I will become what? 2. 2 is also greater than 1, so I will become 1. So next time it will check I is equals to 1 because it is also 1, it is also 1. So iteration, it will not enter into a loop. So how much iteration it done? 4, right? So log base 2 n means what? Log 2 of 16 is nothing but what? 4. And how much operations it will take for any n number? That is depend on log 2 of n. So TC of this is nothing but log 2 of n. I hope this is making sense to you. Try to understand it, stop the video and try to put the values, whatever value you have. So some start from small value to large value, you can say that. So next question which asked by Amazon in an interview. So just think about it, what will be the time complexity of this? Simply just think from I, where it is starting, from 0 till how long it is going? Till n. So just tell me that n minus 0 plus 1 is nothing but what? N plus 1. Got it? So I want to ask you, this is the time complexity for this. This is the complexity for this. Time complexity of this code is, this is wrong. See here, I is 2 and I is less than and not the equal even, but your I is going to double, means if it is 1, if it is, it will take 1 into 1 is equals to 1 into 1 into 2 is equals to 2. If it is 2 into 2 is equals to 4. So I is happening I square all the time, but they have initialized I with what? 0. If you multiply any number with the 0, so output will be what? 0. So the complexity of this is what? Infinity. This loop will go infinity. This will never ever meet to this n, because I will never become a n, because I will be always 0. So if you write this code in Python while loop, so this will go in infinity. You can cross verify. If in cal you can do calculate 0 into 1 is equal to 0, 0 into 5 is equal to 0. You know that if whenever we divide whenever divide or multiply any number with a 0, so always we get the 0 result. So this condition, this I will not meet to your n, and this will not enter into loop, and but this will go where? This will go till infinity, means print of I will print infinity. Okay, this is very basic simple example. They just give a trick some, but you have to look in each corner points. Okay, so let's talk about this. Okay, now this, that is the same example they have asked previous, and this is also same, but in this case your I is what? 1, and your n is what? N only. So means 1 to n you are going. Okay, so 1 to n is what? N iteration. But how it is going? It is going twice. For example, if you have a 8 and if you want to go till 1, so how will go? 4 to 1. How many iterations we have done? 3 iterations. Means the time complexity will be log of 2 of n for this. Just put the values. Log 2 of 8 is nothing but 3. So how many iteration will happen? Let's talk about this. Just take an n is 8. First time I is what? 1. Let's write here 1. 1 into 2 is what? 1 into 2 is what? 2. So next time I became 2 into 2 is what? 4. Next time 4 into 4, what it is? 16. So 16, we have n is what? 8, right? But it is greater than n, right? So it can't, it is not possible. So for 1 it is taking 1 iteration. For 1 into 1 it is 1, 2 into 2 is 4, and 4 into 4 it is taking 16. So actual happening iterations are 3, but actually we are printing this value for 2 time only, because third time it will not enter, right? Your I will become more than n, right? So your n is 8 and it is 16, so this will print 2 time. But if you put, if you are going by twice, if you divide or multiply always into always, suppose any number with 2 or 3, so base will be that. So here base will be 2 and this will be 8, so 3. If you put again to 16, it is 4. Suppose if it is log 2 of 32, it is nothing but what? 32 is nothing but what? 5. So 5 iteration it will take. So this is the time complexity of this question. Got it? Let's talk about this example. Now it is nested loop. You can say this one loop, this is 2 loop. How we can analyze this code time complexity. So here you can't easily solve this, right? First you have to follow a table. I'll show you how to follow the table. Okay, this is your I and this is your J and this is iterations. Okay, so now in this question just tell me that I is what? 1. J is going till what? 1 to always n. 1 to n. So how many iteration it will take? N only. Second time if it is 2, but J is starting from 1 only, right? All the time. So again it will go what? Till n. So n iteration. Now your I is 3, 1 comma n, again n. It is 4, 1 comma n, it is n. So till n it will go, and this will be 1 comma n, and this will be n. Okay, so let's solve this. This is n and this is n minus 1 plus 1 is nothing but n. This is also n. So how many? This is I, this is I. Okay, means this is n, I value is what? N, and J value is what? N. But these are nested. When we follow the nested loop, we multiply, we use a multiplication. But whenever we have a for loop here, but it is not inside this, this is after this execution, then we do plus, means what? Add them. Okay, so in this case n into n iteration are happening. Suppose n is, let's put the value, n is your 2. How much it is? 4. 4 is nothing but 2 raised to 2 means nothing but n into n is what? N square. So time complexity is what? N square. Means suppose if you put any value 4, so how many iteration it will take? 16 iterations. Got it? So time complexity of this n square, n into n is nothing but n square. Okay, let's talk about this question. Just tell me how much iteration this is taking. Never go by this is nested and this is a n square. Never say that. Let's draw table. As I say that this is table for I, this column will be for J, and this will be for iterations. So just tell me that from where your I is going to start? From 0. From where J is starting? 0 to going till what? I is nothing but, in first case, 0. So 0 to 0 means one iteration will happen. You can check, you can cross verify in your editor. So one iteration. Again it will increment by what? 1. I become 1. So again J starting from 0 but going till what? 1. 0 to 1. So how much iteration? 0 and 1 is 2. For 0 1 iteration, for 1 iteration 2. Now it is 3 because it is incrementing. Now again it will go 0 to 3. Now it is what? 3 iterations. Now it is 4. 1 0 1, sorry, it is 2, it is 3. Let me clear this. Okay, I have missed a 2. 0 to 2, 0 1 2. How much iteration? 3. 3 is there, 0 to 3. For 3 plus 1, simply you can say that 3 minus 0 plus 1 is what? 3 minus 0, 3 plus 1 is equals to 4. So how much iteration it will have? 4, right? So I, where I is going? Your I is going till n, and J always follow 0 to n, and this iteration comes n. Got it? So now just tell me that, okay, if it is n, again n into n, this will be n into n is what? N square. Got it? So in this case, if it would have a 10, so this I will take 10 and this will travel till what? N. So 10 n will be the time complexity. So for n it will be n square, and if it is till 10, then it will be what? N square of this question time complexity. Let's talk about this question. We have I, we have j, and we have iterations. I is starting from 1 till where it is going? Till where? J is going till where? It is going till 1 to n. But how it is going? Why twice? So for example, 8 4 2 1 means it is the complexity of this is all we have seen log n. So directly write, it will go till log n. When it is 2, again it is log n. When it is 3, again it is log n. So iterations, how much iteration it will happen? 1 into log n is nothing but log 2 of n. So again 2 log 2 of n. So again log 2 of n. So means this will be n and this will be log n all time, and this will be log 2 of n. So it is nothing but n into log 2 of n. Got it? The TC of this is nothing but n log base 2 n. You can simply see now, this is traveling from 1 to n and this is traveling from j to n, means 1 to n, but it is taking jump of 2. So when it goes double, means base 2, so we say that log 2 whatever n is there. So for this part I have taken this, and for this it is n. So it is nested loop, that's why n into log 2 of n. If it would have like separate loops, so we can say n plus log of 2n. Okay, this is time complexity. So this is your simple. I'll just give you this code and just take and try to solve it yourself. Okay, so let's talk about this. Okay, so this one you try yourself, and this one also try yourself. Okay, and this also try yourself. These three I have given as a homework. You can just stop the video and you can take a picture and you can try to solve it in your notebook. Okay, so let's talk about this, what it is. You are you are surprised, you have surprised right now. See how they made this way. This is increasing. Constant means what? Order of 1 it takes. So log 2n is greater than what? It more than constant. Let's verify. Suppose if you have a number which is 2 in bracket 1, this is constant. Okay, this is constant. So 2 will you will get. So always this, if this change, will this change? No, right? But in this case, suppose if you put, for example, let's put here 8 only you will get. But here how it will happen? Log 2 of 8 is what? 3, but iterations are happening 3 iterations, but this is happening in a single line. So this is 3 iteration, this is 1 iteration, or you can say the single line. So single line is 1 and this is 3 iteration, so 3 is always greater than, so means constant is less than log n and log n is greater than constant. So next, log 2n is less than square root of n. Let's verify. Log 2n and here it is square root of n. Let's put the same value. Log 2 of 16 and it is 16. How much it is? 4. How much it is? See, 2 into 2 into 2 into 2. 4. This is what? 2, 4, 4 to 8 and 8 to 6. So this is also 4. This time it is 4. It is equal, but it not proved that it is not greater. So let's prove again. Suppose if I take log 2 of let's say 20, and here let's put 20. So if you think about this, so it will be not 5, it will be 4 point something, but here it will give what? 4. I told you that if 20 is 2 into 2 into 2 into 2 into 2, so this is what? 4, this is what? 8, this is what? 16, this is what? 32. So now your 20 is rely between this. So which term it is? How much times it is taking? 4 times. 1 time, 2 time, 3 time, 4 times. So how much iteration it will take? It will take 4 iteration. But for this it will be 4 point something, right? Means actual the time taking time is greater than this time. So this is also true, right? If you are not able to understand what, like how I'm trying to prove it, you can also try to prove with your own inputs. Now next is n is less than n square. Obviously everyone know this. If your n is this 2, so n square will be 4. If it is 4, it will be 16. So always your n square will be a greater than n. And the same next thing, n square is less than n cube. Obviously if it is 4, it will be 8 for 2. If your n is 2, it will be a 4 or it will be 8. If your n is 3 now, so it will be a 9 and it will be what? 27. So n square is always greater than n square is less than always n cube. So next is 2 raised to n. N cube is less than 2 raised to n. Obviously this is 3, but this is n. You can't say that how much it is. It can be more than 3, but it will be a greater always. And the last is n naught. So actually we don't go till this, we just go till this only. Okay, just think about this only. So we just follow this time complexity. So always time complexity increases. What? Increases. So if your time complexity, your program is taking this much time, means suppose if your n is 2, means how much iteration it will take? 8 iteration, because 2 raised to 3 is what? 8. Suppose it is 4, 4 into 4 into 4, 3 times, 16 into 4, 64. So means you need to optimize your code with this complexity if it is possible. If it is not possible, then the complexity will be a best or worst. That part we will think or observe later on. Okay. So let's talk about big O. In the first page, as I said that big O, what is big O? That I said that big O, basically big O is what? Nothing but they made one analysis. So instead of talking about the big O, before that I will tell you that suppose if you have a one number, n is nothing but 10, okay, and if you want to draw the graph, it is possible, right? Because it is very small. But if you have a 10, if you have a loop, multiple loops, so that is not possible, right? Try writing or drawing correct or accurate what correct graph, right? So instead of that they came up with what, big O. So they will find the actual the order of the algorithm, okay. So it depend on three factors. Find, if you want to find the time complexity of your algorithm, find the number of iterations. One way is number of iteration, how many iterations are happening. You can say, suppose for an example I said that 100 iteration are happening for each number, means each number. So in that case what you will say, 100 are iterations are happening, so it is constant, right? All time 100 are happening, so order of 1 will be your time complexity. Second, they said take the highest order term. Highest order term means what? I guess you have an idea of simple, that is polynomial expression, okay. Suppose take this example for highest order term. This is 7 raised to 7 into n raised to 2 plus 3 into n plus 5 log n. So if we look at this, okay, so n square is highest or log n is highest? Log n is not highest because n square is here and it is here. In between some time complexities are there, right? So n square is what? Bigger. So highest term is what? N square. So time complexity will what? N square on the basis of second term. That is take the highest order of term. So third is neglect the constant coefficient. So neglect the constant coefficient, it means that, for example, I'll give one example. Suppose here it is Ratan Tata and here it is Adani, okay. So Ratan Tata has a 10 lakh rupees, Adani also has a 10 lakh rupees, but Ratan Tata got a profit of 10 rupees. So can you say that Ratan Tata is a popular, or popular means rich person than Adani? Can't say that, because 10 rupees is nothing. 10 rupees is nothing. He can adjust the 100 also, right? He can also 100, right? Means you have a sea, okay, and you came up with in bucket, okay, and filling and the water inside the bucket, and you just thrown the water inside the sea, okay. So can this water rise your level of water? No, right? So the same thing, this 10 rupees cannot say that this Ratan Tata is a rich person, because this is negligible, right? We can say that like 2.3 and 2.299, this is greater. Practically if you see this is greater, but if you neglect this, what it is? Constant, right? So that's why they say neglect the constant coefficient. So constant coefficient we need to neglect. For example, I'll tell you, this is a 7 plus 3 plus 2 into n. So in this case this is order of 1, this is order of 1. So in this case this is what? Constant. So whatever n will be there, so only 2 going to be multiplied with whatever input size will be there, right? So in this case 2 can be negligible, right? So n, whatever n is there, so you will just multiply with what? 2. So n can be your time complexity and 2 will be your negligible, like you can neglect this coefficient. This is nothing but what? Coefficient. Okay, constant coefficient. So this will be a constant. So all time n, whatever n is coming, so this will be the constant 2. That's it. So let's talk about more example. I'll just clear this. Okay, I'll just zoom this. Okay, tell me the time complexity. Okay, this is 8 n naught plus n cube 3n square plus 5. So highest term is what? This, as we have seen here, right? Same thing here, 5n square root of n plus 3 raised to n square. So square root n is less than n square, so 3 is coefficient, 3 n square, so 3 again gone, and n square is the time complexity. 4n square plus 3n plus 10 raised to 6. So now see here, what will be the time complexity? This is constant coefficient, mean whatever operations will happen, it will take only 10 raised to 6 constant. So you can't say that this is the highest term. Highest term is this. N is will be a vary number, like n will one time it will be 2, 10, whatever. So highest term for this expression is what? N square. So talk about this, 6 into n raised to 3 plus 12 n plus 10 raised to 3. So this is also 3, this is also 3, but this is what? This is constants. This will be a same for this equation. This will never change, but if you put the different value for this equation, n gonna change. So this is also can be a time complexity, but the highest term for a big O we follow, that is n cube here. So n cube is the time complexity of this question. So friends, this was a very basic time complexity lecture. So if you have any doubt, you can just comment it down. So I'm just telling you that you will not find, like you will not see this kind of analysis or this kind of detailed analysis anywhere. So I suggest you keep watching and keep following the all the videos and everything. Okay, thanks